Now, in an established forest fires, right, fire, so the proportion of total area of the forest which is being destroyed is denoted by X. This is X, important. So, and the rate at which X change with respect to time t is called the destruction rate. So, this destruction rate here is called dxdt. Very good. Okay. Now, investigation shows that the destruction rate is directly proportional to the proportion destroyed. Proportion destroyed is X. Proportion not destroyed is 1 minus X. Okay. So imagine this is a forest fire here. So you think about it, right? So let me just draw it out. Okay. We just draw this like forest. So if it's destroyed is here. Destroyed. When they say proportion, is X, right? The total will be 100%, which is 1. So not destroyed is 1 minus X. Okay. Now, so let's try and understand this rate here. You're told that the destruction rate, which is dxdt, right? So the question is, why is it 1? Because proportion means fraction. Fraction just means 100%. So the whole thing here is 100%. 100% is just 1, correspond to 1. Okay. So now you know that, is it easy to start a forest fire at the start? Okay lah. I mean, is it easier to start? Okay, is it a flat rate? Is it easier to start at the start or when it's already on fire? When it's on fire. Okay. So in other words, right, it's actually quite hard to start a fire. All right. But when it gets burning, right, the rate will go up. Am I right? Because you have more trees to actually burn. So the more trees you have, so imagine if you have, if you want to start a fire, it's very hard to start one. But once it gets the fire start raging, you have more area here to expand the fire, right? But will this go up indefinitely? No, right? It will some point come down, because you as you ages to the age of the fire, the forest, you have less tree to burn. Am I right? So that's why the model is as such. So if you look at this model here, this is a cool model here. It's actually a quadratic model. They tell you that the destruction rate is directly proportional to x 1 minus x. Okay, so so this is proportion destroyed, not destroyed. So this is the case here. So essentially, this is actually dxdt x destruction rate. Now destruction rate is already a negative thing because you're already destructing. So there's no negative here. Here is k x1 minus x, where k is a positive constant. Okay, you will already know that k is a positive constant because destruction rate is already considering the one that is being destroyed. So that's why this is a positive, then go down. Okay, the destruction rate will go up, then come down. Okay, you need to know so you really need to slowly do some reading comprehension. Now the next one is, a particular fire is initially noticed. So a particular fire is initially noticed. This is when t equals to 0. Okay. When 1/2 of the forest is destroyed, means x equals to half. One half means half. It's just a very 1/2. It's not 1.5. 1.5 is 1. Okay, one is like 1/2. Sometimes students will think that is 1.5. It's not. So 1.5 will mean 1.5. Okay, 1/2 just means 1/2 literally just 1/2. Okay, so you are looking at 1/2, and it is found that the destruction rate at this time is such that if it remains constant thereafter, the forest will be destroyed completely in further 24 hours. This is the bomb. Okay, this is the damn messed up one. Now, at this rate, we already established the destruction rate is varying, right? So you go up and then you come down, right? You go up and then you come down because it's hard to start a fire, but when you you start the fire, it gets going, it is very hard to stop, like inertia lah. But then after that, because you ages through the forest, the lesser tree you have, then the destruction rate will go down. So now the question now is, if you hold, so at this rate, right? So at t, initially t equals 0, right? The destruction rate, x equals a half. Destruction rate is, if you hold this destruction rate at constant, you will clear it remains constant thereafter. The forest will be destroyed completely in another further 24 hours. So, in other words, this destruction rate will be how the destruction rate is the number of proportion of forest burn over time, right? Am I right? That's the destruction rate, right? Because you are looking at the destruction. Okay, now the question is this: this proportion of forest here is what? The remaining. They say the remaining portion of remaining, right? Remaining is how much? Half. Am I right? Half. Because you say at the start, at the start already half of the forest burned down already. Half of the forest burned down. You left with another half. At the start, you left with another half. And they say that if this it continues at this constant rate here, it will take how long? 24 hours. Okay. This is the one which is the problem. Try to understand it. At the start, you walk into the fire. At the start, you drive your car there already. You realize there's a forest fire. You realize half of the forest is already down. Okay? And then you establish that if this rate were to continue at a constant rate, it will take another 24 hours. The rate will go down. Okay? So that's what they're trying to say. So this case here is you have got 1/2 out of 24. This is 1 out of 48 forest burn. 1/48 of forest burn out per hour. This is the rate they're looking at. This is what you do. This is actually a destruction. This is dxdt when x equals to half. So you just sub all this inside this. You can find your k. Once done, you get sub. To the DE. Okay, sub it in. So this one. So we will get important, you solve this now. If you cannot in exam, if you cannot show this one, just remember you can just solve it. This one can be solved one. Okay, this one is not difficult. So you really need to practice it. So this one here, dxdt, this is 1/12 x 1 minus x. Then your x and 1 minus x separable form. Separable meaning you die put all the x and dx one side. So this case here will be 1/x. Then you just put it on this. I'm gonna do partial fraction for one, but if you don't want to do partial fraction, you can use MF26. Complete the square, use MF26. Okay, but I lazy. Partial fraction. So this case here, I'm going to use cover up method. So A is when this is 0, then B 1. Cover up method. If not, you can always use your secondary school method. Cover up is fast, but only works for linear. T ln x. Then you don't need the okay. So do okay. So we want to find a, right? Equals 0, x equals. So now they say just find, this is what, this is show that this is x. Show x is 0.73, right? Proportion. The proportion that we want to show is this one here. The forest is destroyed in 12 hours after first notice. So this case here is where t is equals to 12 lah. Got it? So when t equals to 12, you know that you need to solve for x. Oh, just E1. Calculator. Group point 0.7. Oh, 73%.